Hello everyone, on behalf of Physics Made Easy Kota, I am welcoming you in our next video lecture regarding the chapter Current Electricity. In this chapter, firstly, we are going to understand about the concept of the electric current. Electric current play a very important role whether we belong to science or not. So at various applications of the electric current we are using in our day-to-day life. So first of all, we are going to understand what is electric current. In actual, electric current is a flow of the electric charges, or we can move that the moving charges make up the electric current. When the moving charges flow in a particular direction through a conductor, then the electric current production take place. So the directed rate of flow of electric charge through any cross-sectional area of a conductor is known as electric current. So let us assume that delta Q be the charge that flowing enough for a very short time interval delta T, then so current that flowing in any time T can be given by capital I, that denotes a current, is equal to limit delta T approaches to 0 delta Q divided by delta T. And we know that for the limit delta Q over delta T will be changes into the dQ over dt. And for the journal, for the total charge flowing in a time small t, then I is equal to Q divided by T. We know that Q is equal to Ne, so we can replace it in the formula, that is I is equal to Ne divided by T. Here small n is the number of the charged particle constitute the current, that is a moving charge particle that make up the current, and E represent the charge on each of the moving charge particle. The charged particles which constitute an electric current are known as charge carriers. There are the different charge carriers in solid, liquid or gases. So number 1, flow of electric charge carrier in metallic conductor. Among the solids, all metals are good conductor of electricity. So the cause of the conductance is the free electrons which are moving, and these free electrons make up the current or the electricity. In case of solid conductors, atoms are tightly bound to each other. There are the large number of the free electrons in them. These free electrons are responsible for the production of the electric current. But in case of the liquid conductors like electrolytic solutions, there are the positive and the negative ions. When the electric field is applied, these ions move and they form the electric current. Whereas for the gases generally behave as the insulator of the electricity, but they get ionized and become conductor at low pressure and the high potential difference. So the ionized gas contain the positive ions and the negative ions, and they form the electric current. Now for the practice, here is a numerical. How many electrons per second flow through the cross section of a conductor so that the conductor carries a current of 1 ampere? We know the formula I is equal to Q upon T, replacing the Q with Ne. Get the formula I is equal to Ne divided by T. Let N over T be the number of the electrons flowing through a conductor per second through the cross-sectional area of the conductor. So on cross multiply the things, formula will be I upon E. I is given in the question 1 ampere is 1.6 into 10 raised to power minus 19 coulomb. On solving this, we get the final answer, that is 6.25 into 10 raised to power 18 per second. That is a flow of 6.25 into 10 raised to power 18 electrons per second through a conductor give rise to the 1 ampere electric current in a conductor. So thank you for watching. Have a good day. Take care.